Okay, so this is an abstract. So this is how an abstraction is basically, to say how we can hide as a programmer, how you can hide. So in this particular diagram, you can see a programmer would be writing this piece of code, and this is the program that you will be writing as a software. So you'll have execution algorithm in your actual program. You'll be having processing of your input data, because there'll be input data because the program requires some input data. Like for example, a web application, it will have some input data, some forms that you need to fill in. So if you got processing data, you got output data, you're generating a lot of output, maybe forms, maybe some documents or something, like maybe PDF documents as an output. So you have that interaction that happens. But keep in mind, as part of an abstract programming model, so the emphasis is to make sure the program that is written assumes how the program runs, assumes what type of input you provide, assumes how this input is processed. So we have to consider an abstract program of a model, which is what is shown in this particular diagram, which is generally taught to us in an introductory programming courses. So they say that your program should take certain types of input data, and your program should produce and it should take data from various sources. It could be coming from a keyboard, maybe it's coming from a touch screen, maybe it is coming from a USB drive, maybe from a serial input interface. So variety of possible sources it can take the data from, and then it is going to process the data based on what your algorithm says. So you have some algorithms that you have written. It may not be one, it may be several. They're always interacting with each other. So these type of algorithms, it wants to interact. So you have to make sure the data is processed according to your algorithm and produces and generates output based on what you expect. So it might be sending to multiple destinations. So you can see we could have a touch screen, a graphics user interface display screen. So the display screen will be showing data, which is data that I can see, and it will also be like touch screen. So I can also touch and enter some selection, because nowadays we've got monitors that can also use as an input, because you can touch and produce an input. You also got regular keyboards and mouses that you use. So you have a keyboard to type, mouse to point and click. You can also have that. And when the program is executed, it will take data from here. It can produce output, and it can also take input from the, even though this particular diagram doesn't show input, so you can put this as bidirectional, which means it can also take input, it can also throw output. Like my monitor, for example, is a touch screen. So I can see the data, I can also touch and send the data, or I can do some selection. It is also going to interact with other programs. You can see with other programs, with the databases, it can also interact with databases and other file systems, maybe like that you have got in partitions and so on. It can also communicate over the internet, okay? Because you have got internet connection, your program could actually send data over the internet. And you can see that it is always running on top of your operating system. So it's always on top of the operating system. And notice that the machine hardware, the other interfaces and other hardware, is quite well protected with the operating system. And the operating system can only give this program access to other hardware through system calls. Okay, keep this in mind. This is a very important concept. System calls that are designed by the operating system are used by programmers to an API, application programming interface. Using system calls, they can interact with the hardware, because hardware cannot access directly. If I write a program, I can't access the hardware directly, such as CD-ROM, USB drives, hard drives, say network controller card, sound card, you can't access directly. If you want to access, you have to take permission from the operating system using some system calls that are all built in through the API, application programming interface. Any programmer has to use APIs to interact with the hardware, to interact with the internet, to go onto the internet using network cards. So obviously, an abstract programming model requires that. Yeah, so you can see all these aspects to interact with each other. It could be very complex, the way that interaction takes place. So you have to keep this in mind when you do, when you try to write a program. You have to, as a programmer, you have to keep that in, keep that emphasis. Okay, that emphasis is to make sure the abstraction model is there in your mind when you're trying to interact. You have to use application programming interfaces. So generally, when writing a program, programmer will typically focus on what is needed, what to be solved, what is the problem the program is addressing, and the attention of steps that he has to do to be successful in its program to be executed. You should have a normal flow of execution of a program. You should be able to interact and understand failures, any difficulties, any problems that it'll have. So always a programmer should be defensive. That's why it's called defensive programming, which means you're assuming the validation of the program. You're assuming all the potential failures that can be handled gracefully, perfectly, safely, and correctly anticipating all those type of checks and balances that are needed for a developer. Anyway, this is basically the overall picture of an abstraction that we are trying to see. This is the image that I've been putting on the other slides just to bring up information. So you have a computer system, you have got your operating system running on it, and you got the machine hardware like your motherboard that has got all the inputs, I/O devices. It has got input like USB devices and network cards and everything that you see on your computer. Excuse me. So when you write a program, of course, you have a program that can be very complex, that can be very simple, depending on what the program is needed. So make sure your program is focusing on the requirement, the needs of the program to solve what, to do what, to address what type of attention is needed, what type of code is needed, how the data flow will be executed in the program. If there's any failure in your code, problem in your code, you should detect it. Okay, so these are the things that you need to look into it. So a defensive programmer means you're always assuming and validating input, handling of input data, handling of output data, sanitizing the data, making sure if there's any potential failure, you should be handle it in a very graceful manner or in an efficient manner so that the data can be processed properly. If there's any error, you can anticipate it and you can rectify it and you can fix those errors. So a programmer has to take all of that into consideration.
The Victorian Institute of Technology has other great videos covering many different topics. Please check them out, and thanks for watching. Remember to like and subscribe the video for more great content like this.